So here is our lesson on slope-intercept form. This goes with lesson 6.1 in your text. The essential question, how can you represent a linear function in a way that reveals its slope and its y-intercept? This EQ and the topic are so directly related, like the topic answers the EQ. And you have 3 I can statements that we're covering in this lesson. I can graph a linear equation written in slope-intercept form. You should be able to do that. Okay, and we're going to cover it so we know how to do that. This is something you learned in 8th grade. Okay, but we're going to remember how to do that. I can rearrange an equation into slope-intercept form. The assignment you had in Delta Math yesterday was doing this exactly. Okay, so the fact that you were practicing in Delta Math and then we're going to do it in this lesson more specifically, you're going to be experts. I can create an equation in slope-intercept form. So given some information, you can write the equation in slope-intercept form. These are the 3 things we're going to be doing today. Vocabulary. So when I talk about slope, when I talk about y-intercept, when I'm saying slope-intercept form, I'm talking about the slope and the y-intercept. These are just numbers, folks. Okay, the slope is a number. It's a ratio. It is something that describes how steep a graph is. It's represented by the letter m, lowercase m. In slope-intercept form, this is slope-intercept form. Y equals m times x plus b. M is the slope. M is the rate. M is the rate of change. M is the constant rate of change. We've been talking about rate of change. We've been talking about slope. It's m. It's the same thing. It's just represented differently, but it's constantly talking about slope. It's a number. And then the other number that shows up here, b, is the y-intercept. The y-intercept, and we talked about what the x and the y-intercept are. The y-intercept is just a number that represents where your graph, where the line of as represented by this, where does it cross? Where does it intersect or intercept the y-axis? We call that lowercase b. It's always lowercase m and b. This is always lowercase y and x. These are all lowercase. Don't capitalize them. Okay? Y and x are the 2 variables. X is independent, y is dependent. Remember, your x's are your inputs and your y's are your outputs. You know, if we're talking about function notation, we can replace the y with f of x, and it means the same thing. But this is slope times x. These are being multiplied together because they're touching. It's implied that they're being multiplied, plus this number here, which is the y-intercept. It's a starting point. It's where you begin when you graph. It's the initial value. It's a constant. It's just a number. Okay, there is a lot of info on this slide. I know that. But I just wanted you to have it to reference. Okay, please do not, when you take notes on this, please do not try to go back and write down all of this. That sounds exhausting. You can screenshot it and add it to some virtual version of notes that you might create. You know, your notes for my class, they are whatever's going to help you. So if you like handwriting notes to use when you take a quiz or a test and reference things, then that's what you're going to do. If you would rather screenshot things and create a document where you have all this information that you're organizing so that you understand it, that's what you're going to do. They're your notes. This is being recorded. You can go back and watch the recording, usually like 20 minutes after class, and you can pause the video and you can screenshot things. All right. Graphing in slope-intercept form. So this whole thing here, this is reviewing what you learned in 8th grade. So let me help you remember. Y equals mx plus b. So these are just like a little memory trick. If you think of 2 words that start with M and B, beginning means you start here. This is where you begin with. Begin with this. And then M means what you move. How do you move from where you began at? We're talking about graphing a line. It's going to be a straight line if it is in slope-intercept form, of linear. It's linear. It's a straight line. It could be going downhill like this. It could be going uphill like this one. It could be flat. It could be vertical. All of those would be functions except for the vertical line. All right, a function cannot be a vertical line. That would fail the vertical line test. So step-by-step method to graph alignment in slope-intercept form. So here's your slope-intercept form. In general, y equals mx plus b. All right. Step one, you find the slope and the y-intercept from the equation. So if you're looking at an equation in slope-intercept form, the slope stands out and the y-intercept stands out. All right. And if I come back to something else real quick. This was exactly your question. What two values can you easily recognize from an equation written in slope-intercept form? Well, you can easily recognize the slope, and you can easily recognize the y-intercept. Those are two values that we need. So this is an example where we have the equation y equals x. Now, y equals mx plus b. If you don't see something in front of the x term, remember there's that invisible 1. The coefficient is 1 if you don't see it. There's also invisible 1 in front of the y. But that's why m equals 1 for y equals x. The y-intercept, well, what's being added to x? There's nothing here. So if I wanted to add a number, I could always add 0. So in this case, this is the most basic of linear equations. Y equals x, and the slope is 1, and the y-intercept is 0. So when it gets graphed, step 2 says plot the y-intercept. Y-intercept is 0, that means I cross the y-axis at 0. And anytime you have a y-intercept, the x-coordinate is always 0. The y-coordinate would change depending. It's always going to be somewhere on the y-axis. But for this basic equation, it's at 0, 0. Then, step 3, plot the second point using the slope m, which is rise over run. Change in y over change in x. We've been talking about this, which is the same as when you subtract the difference of the y values and divide it by the difference of the x values. So if my slope is 1 for this basic equation, and I want to think of it as a ratio, 1 is the same as 1 over 1. So if I rise 1 unit and I run 1 unit, and I plot a second point, and then draw a line through the y-intercept and the second point. So from here to here, I connect a line, and that is my graph. If you're using some type of computer program to graph, you only need 2 points to graph a perfectly straight line. If you were doing this by hand, you should plot more points. So you would rise 1, run 1, make a dot, and then repeat the slope over and over again. Rise 1, run 1, make a dot. Rise 1, run 1, make a dot. And it would keep going until forever, okay? So this is how you graph in slope-intercept form. All right, let's see, were you listening? Go ahead and answer this question. Which variable in the slope-intercept form represents the slope? Go ahead and go to your pear deck slide right now and answer this for me. Are you paying attention? Go to your pear deck slide, answer this question. Leave the meat, go to your pear deck slide. Not what, let me rephrase that. Don't leave the meat, but just go to the tab for your pear deck slide and answer this, please. I have one response. Come on, guys, we could do better than this. Which variable, remember a variable is a letter, in the slope-intercept formula, or slope-intercept form, which one represents the slope? Which variable represents the slope? Which letter? 3 responses. Oh my gosh. One person has it correct. Of these 3, one of you is correct. Slope, right here, is M. The slope is M. Lowercase m. Lowercase m. The slope is M. Okay. This is a video you're going to watch in a minute. This is a question I want you to do. This is an example I want you to look at. This is a question I want you to try. This is a video I want you to watch. This is an example I want you to look at. And this is an example or a problem I want you to try. All right? I'm going to give you some time starting here. You're going to start by watching this little video, and then you're going to go through and try the interactive slides and go through the examples. On my side, while you're doing this, I realize that if I mark a little star next to your answer, you don't get to see that. That's for me for some reason. So instead, if you try a question, I will give you feedback as quickly as I can, either saying yes, and that means it's right, or try again, which means try again. Okay, I have to keep the response really short because I do want to give as many of you feedback as I possibly can. So you are on student-paced mode until how long? Let's see. This is period 3 until 11:30. Wow, 8 minutes. I had to talk a lot. So go ahead, spend 8 minutes, and then we'll go over it. Okay. I'm going to show you how to do this in the Google Meet. So do me a favor and just toggle back to the Google Meet. This is the only problem we're going to go over today. I'm going to give you time tomorrow to do the rest of this, go through the rest of the videos and the slides, right? Because it's just too much for this class period. We're going to graph y equals mx plus b. And when you do that, you need to identify what's b, what's m. And in this picture, our m is right here. Our b is right here. So you're always going to start with b. B is 2, and that always goes on the y-axis. So if I find 2, it's right there. And then from that, I'm going to use the slope, which is 3 over 4. So that means I rise 3 units. So going up from 2, I go to 3, 4, 5, and then I go over 4. It puts me here. Now, I'm going to keep repeating that so I have enough points to make a very straight and perfect line as possible because I'm doing this by hand. So from where I'm at, I'm going to rise 3 more units and run 4 more over. And now I'm going to reverse that pattern. So I get points going the opposite way, which is to go down 3 and to the left 4. Down 3 to the left 4. And repeat it again. Down 3 to the left 4. And then I can, I'll use my line tool here, draw a line going through these points as best I can. And then I'll put arrows at the end of my graph. Okay, so this is what you want to do for slide 6. I want you to go back and fix slide 6. You still have 3 minutes. This is what you need to do to slide 6. And we will continue with this lesson in student pace mode tomorrow. Okay, You'll be in student pace tomorrow and you'll go through and finish the rest of it. And then I'll post probably a video for you explaining the rest of it